So here we discuss latent heat and specific latent heat. So what is latent heat? So consider heat energy is absorbed by solid during the melting. Okay, an equal amount of heat is liberated by the liquid during freezing. The important thing is that they are all are showing any change in temperature means a fixed temperature. So when heat is absorbed by solid means ice to water. Some consider that latent heat means ice 0 degree centigrade ice to 0 degree centigrade water. Temperature is fixed. Some heat is absorbed here. Okay. Some delta Q amount of heat is absorbed. Similar case or vice versa. Temperature is fixed. So heat is liberated. So liquid turn into solid. Similar, now another case is that in case of vaporization, so equal amount of heat is liberated on vapor during the condensation. Okay, actually means the heat is absorbed during liquid to vapor, but temperature is fixed. Similar case, when its heat is released, when that vapor to liquid case is called a condensation, but in that case both cases are temperature is fixed 100 degree centigrade in example of water. So what is latent heat? So latent heat that latent heat, the heat energy absorbed, the heat energy absorbed or liberated okay, in change of phase means a solid to liquid and liquid to gas or gas to liquid, liquid to solid. Okay, this is phase change of phase is not externally manifested, is not externally manifested. Okay, or temperature is fixed. Temperature is fixed. No change in temperature. So that amount of heat, when I think absorbed or liberated, that heat is called latent heat. Latent heat. Okay. So latent heat expresses the unit of mass of a substance is called specific latent heat. So what is specific latent heat? So specific latent heat. Specific latent heat that the when express a specific latent heat that is equal to some heat is absorbed or released by mass but temperature not change, only phase change, only phase change is called specific latent heat. Means that is L equal to, here you get L equal to Q by M. So SI unit is heat is joule, mass in kg means joule per kg. The SI unit of latent heat. Okay, so now write a definition. Either heat is absorbed or heat is released. Okay, that depending on which state from to where. Okay, if means I think ice to water means you know that is called melting. So latent heat of melting. Okay, reverse process is called freezing. Latent heat of freezing. Okay, so now the definition of latent heat. The definition of specific latent heat. The specific latent heat. Specific latent heat unit of a phase of a phase is the quantity of heat is the quantity of heat is the quantity of heat energy heat energy absorbed or liberated by the unit mass. Very important, right? The unit mass by the unit mass of the of the substance for the changing in phase at a constant pressure for changing phase at constant temperature. Constant temperature. This is called specific latent heat. So what is the unit of specific latent heat unit? So unit of specific latent heat. So suppose take a consider one kilocalorie KCl kilocalorie per kg. Okay, so consider kilo means 1000 calorie. Now convert kg means 1000 gram. We cancel these two, so that means 1 calorie per gram. So 1 kilocalorie per kg, that is also equal to 1 calorie per gram. And 1 calorie per gram, 1 calorie is noted that is equal to 4.2 joule amount of heat, that is per gram. Okay. Okay. Now if 1 calorie per gram, if I multiply 1000 here, top and bottom, joule per gram here, means 4.2 into 10 to the power 3. So 1000 gram means kg per kg, joule per kg. So here we write that is 4.2 kilojoule per kg. That's also the units. Okay. Now we discuss specific latent heat of fusion of ice. Okay. So what is the specific latent heat of fusion of ice? Specific latent heat of fusion of ice. So what is the specific latent heat of ice is defines like that. Is the heat energy required is the heat energy required to melt the unit mass of ice, to melt unit mass of ice at 0 degree centigrade to water at 0 degree centigrade. So state or phase may be changed from ice to water, but temperature is fixed. On the other hand, specific latent heat of freezing means same. Specific latent heat of freezing, similar. Specific latent heat of freezing. Okay, freezing of ice Similar condition here. So here water is the heat energy required. Now heat energy release. Okay. So heat energy is released. So here the important change is required here to release from water from water to ice. From water to ice. So liquid to solid. But temperature may be 0 degrees centigrade of liquid water to 0 degrees centigrade of ice. So heat is released. So that heat is called that heat. These actually this heat means this heat is called specific latent heat. This heat, the heat is called specific latent heat. Is called fusion means solid to liquid. Here is freezing means liquid to solid. Okay, that's the main difference. Phase change, but same amount of heat is actually needed. Okay. Now explanation of latent heat of melting of basic some kind of basic kinetic energy model. Previously we discussed before that we just draw a graph. Actually draw a graph. Uh, we draw a graph here for better understanding. Here is the temperature and it's a time. Okay. Some consider that is a here that is a here is 0 degree centigrade. Here is 100 degree centigrade. Time also called as heat. Time consider the heat, not time. I actually ignore that time. Here plot only heat. Okay. So here see that the diagram here at that point. Okay. From heat is increasing. So temperature also suppose minus 30 degree centigrade to 0 degree centigrade. So heat is increasing here. So heat is increasing, but state becomes solid. This is solid, no change. But at that point here, very important, at a point here, heat is increasing. Heat is increasing. Something that, but temperature is constant. But temperature is constant. Temperature is not increased at that point here. After that, the heat is also increasing. Means heat is suppose the heat is absorbing. Okay, actually heat absorbed here to the heat is released. So now temperature is also increasing at that point. Okay, actually see here there's the important thing that suppose this heat is called some delta Q1 amount of heat. Here you see that here is the ice. Consider the water, that is the ice at 0 degree centigrade. Here water state change at 0 degree centigrade. Temperature constant but heat is increasing. So that heat is called latent heat. It is called latent heat. Means temperature is constant, a fixed temperature, but state will change from ice to water. If ice to water, this direction, ice to water, that direction is called latent heat of fusion. And if a water to ice is a latent heat of called freezing. Okay. Now heat is increasing, so some temperature also increasing 0 to 100 degree centigrade. But here is 100 degree centigrade at that point, similar that 0 degree centigrade. Heat is increasing here, but temperature is constant. But temperature is constant after some time. Temperature also constant. So here we get the 100 degrees centigrade of water at that point. Heat is also absorbed, and here at that point it is 100 degrees centigrade of vapor. Okay, so these the state may be changed. May not actually state change, not may be. That is state change from liquid to gas. But heat also change. Heat is absorbed if liquid to vapor means heat is absorbed. If vapor to liquid, heat is released. So at that point, some amount of heat is needed. That is called delta Q2. That heat is also called latent heat. If liquid to vapor is called latent heat of boiling, okay, and or latent heat of vaporization. And if a back process is vapor to liquid, so it's called latent heat of condensation. Latent heat of condensation means heat is released actually. And here water to vapor, heat is absorbed, and vapor to water means heat is released. So that is the latent heat. The latent heat, no formula. What is the latent heat? That is equal to uh, uh, Q by mass. That is latent heat L. L equal to Q by M. Okay. So actually, you see that the Q proportional to M, A that is the L is constant. That is equal to M L. L is constant. A fixed value, but depending on material. That is a material. Depending on material. Clear? The graphical representation. Temperature and heat is released. Heat is absorbed. Now we discuss the what is the latent heat, a basis of kinetic model. Latent heat from melting. Latent heat of melting on the basis of kinetic model. On the basis of kinetic model. Model. Okay. Suppose what is the melting? Melting means solid to liquid. Okay. When solid changes to liquid without any change in temperature, so kinetic energy molecule does not change. Okay. So here we see that that is kinetic energy not change. The actual average kinetic energy. Kinetic energy molecule does not change. The separation between molecules on the average is increased. So actually that is two molecules. That space is called separation between two molecules. And here is a force or intermolecular force. This force here, that is some energy. When solid to liquid, actually when solid to liquid, okay, liquid without changing temperature, a fixed temperature, we see that the average kinetic energy molecule does not change. Kinetic energy of average is fixed, is not change. Okay, but the separation between the molecule of an average, the separation is increasing. The important thing, the separation average separation is increasing. Important. Average separation between the molecules also increasing. That's some energy required to increase in the separation. And if separation increasing, so need some energy. If separation increasing, so need some energy. Need some energy. Need some energy. Okay. Some energy required to increase the separation against the attractive force between the molecules. So that energy actually, here that is intermolecular force, and that energy needed to against the intermolecular force, opposing intermolecular force, the intermolecular force, or actually attractive force between two molecules. If they increase the potential energy molecule, so actually we increase potential energy of molecule. So some there is some increasing volume. So volume is negligible. Okay, there is some increasing volume. That will negligible volume. So heat is used for volume expansion. So no heat is used. So actually, is volume increasing ignored. So ignore volume increasing because very small amount of volume increase. So no heat energy is used to volume expansion. So actually no heat is used. So no heat is used for volume expansion. Okay. So heat energy supplied during the melting is utilized only the increasing potential energy. So that time heat energy supplied. So heat supplied only increasing supplied melting only increasing the potential energy. Actually here the melting is potential energy, increasing potential energy of molecules also increasing. Okay, molecules. So that potential energy is increasing is called, so that heat, actually the heat increase, that heat is called latent heat of melting. Clear? So what is the latent heat of melting? Clear? What is the basis of the kinetic model? Next we discuss the natural consequence of high specific latent heat of fusion of ice. Some taking some examples. Some examples. So okay, so natural consequence of high specific heat, latent heat of ice. So the mountain does not melt at all once. So mountain ice in mountain tends, does not melt at all. Does not melt all at once. Okay. Why? It's important why mountain ice does not melt at once. Because the reason is that the ice has high specific latent heat. The ice high specific latent heat, that is almost equal to 3 that is given actually 6 triple zero joule per kg. That is a latent heat of ice. Okay, that means fusion. Okay, due to the fact that the energy from sun, if ice to now melting, there's some need of energy. That energy comes from sun. The latent of ice is being low, the snow would have the melted in short time, but getting latent on the getting latent heat of sun. But there would not flood in rivers and water, no water after that. Actually, latent is a very high. Is some energy needed from sun, energy from sun. That is very small amount of energy to melt all ice at some time. Okay. That's why ice has huge specific latent heat. Very high, very high specific latent heat. Next. Okay. So in cold countries, water in lake and pond does not freeze at all once. Similar concept. The reason is specific latent fusion of ice is also very high. Mm. Uh, Same concept. Okay. Drinking the colder is more quickly by adding a piece of ice than a ice cold water, because the 1 gram of ice is 0 degree centigrade means 336 joule. Okay, heat energy is drink to water at 0 degree centigrade. Similar does the drinking liberated by additional heat is 336 joule. So 1 gram of ice to 0 degree or 1 gram of water. So that is cooling of produced by 1 gram of ice of 0 degree is much more than 1 gram of water at 0 degree centigrade. So ice is more cooling, okay, compared than because of water. And the consequence is that when the ice in frozen lake start melting, the surrounding becomes very cold. That's very important. When ice turns become melting, the heat is absorbed from surrounding. When surrounding heat is absorbed, the surrounding temperature always falls. That's why surrounding area is become very cold. Another consequence is that in generally more cold after a thunderstorm when ice is melt during the or before that hailstorm. So reason is that after the hailstorms, the ice absorbs the heat energy. It requires a melting from surroundings so that the temperature of the surrounding falls farther down, so you feel more cold. There is some basic consequences. Read the book actually. Okay, given the books. Okay, concept books is very good. So we complete the latent heat portion, and next class we discuss some numerical. Okay. So today end the class here. Thank you.